Hi, calculus students. After class, I didn't feel great about the way that example 3 went. So I'm going to make a short video of the process that I think that you should go through that I think will better prepare you for the homework assignment tonight and to be prepared for tomorrow. So the first thing that I'm going to say is, remember up here how we used a few different notations to represent these things. And I had my units up here. I can't remember who asked in class, but they asked, oh, what happened to time? And I said, it's okay because time is here. And then I realized, no, when we write the units, this still represents change. So John and inches kind of represent each other, and time will be represented with year. So we actually do want this per year up there, and this one would be per day, per second, and per hour. I'm really sorry about that. And another thing, I think for example 3, we should maybe go back to using this notation, so that you see it with prime notation as well as this df dt or dy dt notation, and then you can choose which notation is most useful for you. Okay, so going down back to example 3, a right triangle has sides 30 and 40 inches whose sides are changing. Remember, we labeled these short side, long side. So I'll say short side is h, and h equals 30. I need to zoom out. H equals 30. And then long side is 40. So L equals 40. Those are just what's given. Given information. So the area of this, area equals 1/2 HL. So my change in area, if I use the other notation, is going to be d8 dt equals 1/2 h. So I left h the same, and then I can take the derivative of L, and that would be dL dt plus, and now if I take the derivative of h, that's dH dt, and L stays the same. So this is how it would look like as opposed to the prime notation. Okay. And then my hypotenuse will still be the square root of h squared plus L squared. And this will be dH dt equals 1/2 squared is the negative 1/2. Oh, my head, sorry. Times, and now here's going to be what's a little different. So 2h, and we took the derivative in terms of h, so it's dH dt plus 2L dL dt. Okay, so this is the derivative on the inside, 2h dH dt, since we took the derivative in terms of h, and this one's 2L dL dt, since we took the derivative in terms of L. So just a reminder of how this would look implicitly. So to simplify this up a little bit, I have h dH dt plus L dL dt over the square root of h squared plus L squared. the 2's all cancel each other out. So those just go away. So then if I do let's do B, I guess, since I already did sum of part A. So B, I have the short side is increasing at 3 inches per second. So dH dt equals 3, and the long side, so dL dt equals -5, because it's decreasing at 5 inches per second. So if I plug this into my change in area, I get dA dt equals 1/2 h, which I was given in the original problem is 30, times dL dt, which is -5, plus dH dt, which is 3, times 40, which is L. So this equals 1/2 of -150 plus 120 equals 1/2 of -30 is -15. And then the change in a hypotenuse, dH dt, again we take what we have and plug it all in. So h is the short side, which is 30, times dH dt, which is 3, plus L, which is the long side, 40, times dL dt, -5, over the square root of h squared, which is 30 squared, so 900. Oops. And then plus 40 squared, which is 1600. And I'm just going to put all this in a calculator. So 30 times 3 plus 40 times -5 divided by the square root of 900 plus 1600, which I think is 500. Okay. So that's -2.2. Okay. So I think the main thing that I want to get across is you might want to use this notation so that it helps you remember when we have to use the chain rule and include the dH dt, because I don't think we did that properly or for this particular equation in class today. So I just want to emphasize, when you're taking the derivative of one of the variables implicitly, you need to include the dH dt and the dL dt, similarly to how we would add dx dy or dx dx or dy dx. Okay. I will stop talking. Message me on Schoology if you have any questions about this. Thumbs up. Bye.